Good evening. It's lovely to see so many people here this evening, back in person again. So tonight we have another very special evening. Not only do we have our evening presentation, but we also are here to present the James Clark Medal winner for 2021. So this evening I would like to start the proceedings with that this evening, but prior to that I do have a couple of emergency procedures that I need to run through. So number one, I've been told we have not due to have a fire alarm, so if there is one, please evacuate the building via your nearest fire exits and follow through to the meeting place, and not collect any personal belongings. The fire exits are in all rooms and corridors. Assembly point is at the corner of Little Great George Street corner and Parliament Square. And also, just a reminder, please put all of your phones onto silent so that you can Divik, who is going to introduce tonight's James Clark Medal winner.
Thanks, Kate. Do a fancy slide. You do get to see him in person as well, but that's for the people on YouTube, so. Second, hopefully this works. So good evening, everyone. To begin with, I'd like to extend my welcome to those who are returning back in person for the first time since we've resumed our in-person events. The past year has been unprecedented, but 2021 also saw us return back to delivering in-person event, which is quite a good thing. Two more good things happened in 2021. Quins emerged victorious in the Premiership Rugby. But most importantly, and that's why we're here today, Bob was declared as a recipient of the James Clark Medal. And today is finally the occasion where we get to present Bob with the medal in person. Of course, before we proceed, I would like to remind you about the significance of the medal itself. James Clark worked for Charles Branson's son on well-known tunnels and died in his early 60s. In 1981, his wife, Madeline, bequeathed a sum of money to provide a medal to be awarded annually to British tunneler who perpetuated James' memory. The original criteria were contemporary achievement in tunneling, innovation or responsibility for a large project. In mid-1980s, though, the medal was not awarded, and with Madeline's approval, a third criteria was added, which was major contribution to the tunneling industry. And of course, today it gives me immense pleasure to introduce Bob as the recipient of the 2021 James Clark Medal. Well known and highly respected within our industry, Bob has held many influential roles, including the chair of British Tunnelling Society between 2010 and 2012, of course, the chair of National Working Group for Tunnelling National Occupation Standards, chair of Construction Skill Network Technical Reference Group, chair of Tunnel Skills, and non-exec director of London Excellence. With a passion for education and training, Bob has been a driving force behind national vocational standards and qualification, and of course the construction management module of the Tunnelling MSc at University of Warwick. So a bit about Bob's work history. Bob worked for Taylor Woodrow for 33 years, starting out in nuclear power and then moving into tunnelling in the 1970s. He led positions on a wide range of major, mainly tunnelling projects, including Piccadilly line extension to Heathrow, Newcastle Metro, the Channel Tunnel, of course the Thames Tunnel refurbishment, and the Jubilee line extension. When he left Taylor Woodrow in 2000, he was, by the time he left Taylor Woodrow in 2000, he was the director responsible for tunneling and foundation engineering there. Of course, in 2000, Bob was the founding manager of London Bridge Associates. The company has since expanded steadily, today employing more than 50 staff with a wide range of experience and expertise. As well as steering a growing company, Bob also held senior positions on projects such as Channel Tunnel Rail Link, Holmesdale Tunnel refurbishment, King's Cross Eastern Range, and in addition to key advisory roles on many other projects. In 2017, he retired as the chairman of LBA, yet continues his involvement with the company as a non-executive director. An inspiring leader with a wealth of knowledge and experience, Bob has remained approachable, down to earth, and a great company. Never one to stand on ceremonies, he's often described as an expert at bringing out the best out of everybody by many of his colleagues. He has also led by example to instill a culture of collaboration and cooperation. So Bob's nomination for the James Clark Medal was for his long distinguished career in tunneling, dedication to the BTS, and commitment to developing young tunnelers, which most of us in the industry are quite familiar with. When asked about his recollection of working with Bob, another familiar face within the industry, and of course another James Clark Medal recipient, Martin Knight, said, "I first met Bob in 1991 on London Electricity Beach Street Cable Tunnel when he was working for Taylor Woodrow. And I was with Howard Humphreys, and the tunnel drive narrowly missed one of the massive pile grids underpinning the Barbican apartments of city lawyers, bankers, and the city worthies. We worked below CERN in Geneva on the Large Hadron Collider tunnels, and below Rotherhithe and Wapping on Brunel Thames Tunnel, and also in Dublin Port Tunnel just after LBA was formed over 20 years ago. And having admired LBA from afar, I joined Bob and LBA colleagues in 2017. Bob has led by example and is consistent in his professional value and follower of the 3 C's: competence, communication, commitment. Recently, LBA worked on a US railroad tunnel refurbishment plan between West Manhattan and the shores of New Jersey under Hudson River. We were facing up to Amtrak, time-serving naysayers who insisted that in-service nighttime possession for engineering refurbishment couldn't be done on their railroad. Bob remained consistent to his value in demonstrating to Amtrak and New Jersey Transit that by committing and communicating a competent plan that the 3 C's applied, the 3 C's applied just the same railroad tunnels in New Jersey as they do for tunnels on the London Underground. Bob is more than the sum of his experience, he's a leader. It's very rightly said, Martin, because Bob's role as a throughout leader in the industry, shaping direction on issues including management, risk, particularly catastrophic risk, relationship building, health and safety culture, and driving agenda of collaboration, communication, and competence, as well as bringing fresh ideas and direction to situations, firmly met the criteria for contemporary achievement in tunneling. Additionally, Bob's experience of more than 50 years in the construction industry also brought many opportunities to demonstrate innovation and responsibility for a large project. This included his pivotal role in establishing and operating London Tunnel Alliance and CTRL, which brought 4 large civil contractors and the client representative together, bringing huge benefit to all parties, where the engineers worked seamlessly across project boundaries, concentrating on engineering with a best for project attitude without commercial barriers that usually get in the way. The result was delivery on budget and ahead of time, and a widespread praise for a model that many still believe should be adopted for future large infrastructure projects. And I think it's something most of us dream of but seldom achieve. Now, you can't know of Bob and not know his passion for knowledge sharing and competence. Through his involvement with the BETS and other industry bodies, he has made major contribution to the tunnelling industry. During his term as the BETS chair, he played an instrumental role in setting up the MSc in Tunnelling and Underground Space at University of Warwick, a course quite a few of us present in this room today graduated from. Bob's involvement in the MSc did not stop at its establishment. Since the beginning, he has been a lecturer and a module leader for construction management module, where his experience and knowledge helped develop the curriculum. Having sat through Bob's lectures in the MSc, having experienced them firsthand, it was delightful to see that his energy, inquisitiveness, and genuine interest in people's opinion inspired so many of us in the room. Over the years, that inspiration has never ceased, and is yet again another reason why I'm stood here today. I can say I've known Bob for 5 years now. Apart from our love of great music, we also share a passion for all things tunnelling and making a positive contribution towards its future. But if I may, I think my dedication towards the BTS so far has been motivated drastically by Bob's dedication towards the people of our industry. And I'm not the only sort of past BTS YM chair who he has inspired. So thanks, Bob. Personally, on behalf of the BTS YM fraternity, and of course on behalf of all the MSc alumni out there. But I also ought to thank you for another thing. Probably risk being a Saracens fan, but you helped me see that there's nothing like the mighty Quinn. And at the same time, giving your continuous service towards the industry, and many who have learned through you, I'd also like to say, yeah, you'll not see nothing like mighty Ibel. So, over to you, Bob.
Well, there you go. That was Divik, most embarrassing. But I really thank you for your kind words. And yes, you caught some of my passions very well. I've got a bit of paper here, and that's to make sure I don't talk too much, because I'm absolutely prone to that. So I'll keep it short. It was a special moment when I received the letter from the BTS advising me that they'd selected me and why. The letter's contents actually made me blush a little with its warm praise and recognition of things achieved. But it was a very uplifting letter, and I thank you for that, Madam Chairman. It really was. It is indeed special to be appreciated and honoured by one's peers, and convinces me once again that we have a unique society which is committed to the education, knowledge sharing and training not only of our members, but of all who are sufficiently interested to join our courses or our meetings. It's also an honour to be following the footsteps of many tunnellers whom I have admired and taken inspiration from. But I'm Also thankful for the 55 years of working in the construction industry, 45 of which have been in tunnelling, and reflect on what an enjoyable career I have had and the great people I've worked with and who have inspired me, helped me, supported me, mentored me, and corrected me when necessary. First in line, of course, is my wife Trish, who's put up with me for all these years and always been supportive. But then also people like Roy Broadhead, who some of you won't know but is passed on, Maurice Gooderham, Di Haycock, Ross Mackenzie, Frank Cardiff, John Keyes, Simon Taylor, and close personal colleagues with whom I have teamworked, particularly Terry Crabb, Simon Morgan, Martin Knights, Kevin McManus, Ken Spivey, and especially, and he's not here tonight, unfortunately, he couldn't be, David Sharrocks, without whose counsel, support and inspiration, I would have achieved so much less. This isn't the Oscars. I'm not going to make a speech about changing the world, but I would like to make a plea for some of the work that I've been involved in with BTS, CITB and Tunnel Skills. I want it to be supported, to be sought after and allowed to become the mainstream. I refer to the themes of my Harding Memorial Lecture and articles by myself and Martin Knights in Tunnelling Journal, Tunnels and Tunnelling, New Civil Engineer, on the future of our industry. And collaboration, communication and competence, because I believe these are the way forward, and I want tunnellers to lead the way. Ladies and gentlemen, friends and colleagues, British Tunnelling Society, I thank you for this award.
I think you can all agree with me that that is a very well-deserved medal. And for someone that took a little tear to my eye, as someone that says that it was not a speech about changing the world, but I think for many of us here in the world, in the tunnelling world, and myself included, I'm certainly very glad that you have made some quite incremental and significant changes to our tunnelling world for the better. So can you join me again in giving Bob a very large round of applause? So that brings us on to our second part for this evening. So this evening, our talk is on digital twins for condition assessment of Brunel's rail tunnels and future applications. And we have two speakers with us this evening. So our first speaker, and correct me if I've got this order wrong, but we have Anmol Bedi. Dr. Anmol Bedi is a chartered engineer with principal experience in design and construction of tunnels and underground structures in both soft ground and fractured rock masses for both mining and civil infrastructure. Anmol graduated with an honours degree in civil engineering from the University of Wollongong in 2002, gaining an MSc in mining geomechanics from the Western Australian School of Mines in 2009. In 2013, Anmol was awarded a PhD from Imperial College London for his research in quantifying uncertainty in rock engineering at the Royal School of Mines. Anmol has been a consulting engineer from 2003 to present and started Bedi Consulting in earnest in 2016. Recently, Anmol has developed a keen interest in digital engineering and bringing efficiencies to tunnelling through the use of technology. Anmol is supported in this endeavour by all the exceptional engineers at Bedi Consulting who share the same passion and drive to deliver excellence through practical innovation. We also have with us this evening, we have Marco Invernici. Please apologise if I've pronounced that incorrectly. Marco joined Bedi Consulting in 2015 after a 3-year site experience with BAM Nuttall on the complex upgrade of London Underground's Victoria Station, where he worked as a survey and monitoring engineer and later as an assistant SEL engineer. Marco's expertise and experience includes developing intricate construction sequencing for complex underground schemes, where he has applied 3D CAD modelling to visualise details and so virtually see ahead potential difficulties and solve them on the desktop before actual construction. Marco also has a wealth of experience in surveying, instrumentation and monitoring, where he has similarly applied and developed digital tools to analyse large data sets and simply visualise this information from practical use. Alongside work experience on the detailed design of new tunnelling schemes and remediation projects on operational tunnels, Marco has worked on expanding Bedi Consulting's digital engineering capabilities with the development of applications for innovative condition assessment and structural monitoring. He also serves as one of the 3 BTSYM representatives on the BTS Technical Subcommittee, and I welcome both of you this evening.
Thank you very much. Thank you.
Okay. And I'll invite the first speaker to the stage.
Okay, thank you. Thank you very much, Kate. Thanks, everybody. It's a pleasure to be here. I think I'm honoured to be be the follow-up act, actually, of Bob's medal. I think we stand on the shoulders of giants when, people like Bob have developed a lot of the stuff that we're talking about here and trying to progress into future technology. So I think it's actually very fitting for us to be giving this this talk on new applications and digital twins, etc., for designing and protecting the historic assets. Okay, so that aside, just an outline of our presentation. So thanks for the introductions, Kate. So what I'm going to talk about at the start is just innovative use of laser and photogrammetric surveys for the condition assessment of brick tunnels. So Marco will develop on this with case studies that we've done in the past. I think I'm going to start a little bit more high level and just look at what digital twins are and how we apply them, or how we can apply them in tunnelling. And Marco will follow this on with more case studies of cast iron line tunnels that we've developed these and used these techniques in. And I'll just round up with some future applications, a bit more blue sky thinking of perhaps how we can develop these technologies in the future to help facilitate tunnelling from throughout its life cycle, actually. Right, so what is a digital twin? I did what everybody does straight away. I Googled it and went to Wikipedia, and I found this definition of what a digital twin is. There's a lot of talk at the moment of digital twins and digital engineering in construction. So Wikipedia, I won't go through all of it, I'll just read what's highlighted. A digital twin is a virtual representation that serves as a real-time digital counterpart of a physical object or process. So I think that's true. Another website from IBM, this one elaborates a little bit, says the digital twin works across the life cycle of the asset, and I think that's very key. And it enables learning, reasoning, and dynamically recalibrating to improve decision making, which I think we should take on board. And finally, an unknown blog, but I thought the words here were very good. It says that a digital twin is a bridge between two worlds, and it is used to analyse data and monitor systems to prevent issues before they occur and to prevent downtime. So I think that to me was very apt. So I think as a whole, my opinion of what a digital twin is and how it should be used, taking away a few key points, I think it is an accurate model of a physical structure. It is a tool which is useful for visualisation, and learning about the physical structure itself. It contains valuable data for planning, reasoning and decision making, and it should be used across the life cycle of the structure. So not just a model for planning, etc., but across the life cycle of the structure, to capture data, monitor the structure, and analyse it to identify issues and prevent downtime, and plan ahead preventative maintenance. I think Divik gave an example of the Amtrak that Bob worked on, working on night shifts and preventing disruption. It's not just a 3D model. I think I'd like to emphasise that. You don't just build a CAD model and say that's a digital twin. I don't think that's what it is. Everyone might have different views, but this is my opinion of what a digital twin is and how we should use it. Now, moving to tunnelling, so digital tools for tunnelling and the life cycle. So everyone knows very well there's 3 key stages in the tunnelling life cycle. So excavation of the ground, whether it's rock or soil, lining and support installation, and then during operation, asset maintenance and renewal. So how can we use these across the life cycle? How can we use digital twins across the life cycle? What I've done is I've put together a few slides for each of those stages and just listed out the sort of tools, and many of you in different fields, from consulting engineers to contractors to asset owners and insurance people will see the need for some of these. So during the excavation life cycle, where can we use it? So it can form an excavation record. So we capture a digital twin of the ground as excavated, and that stays on board as a record forever, an accurate record forever of the ground conditions, and we can use that. We generally cover up the tunnel with shotcrete or segmental linings, and then it's gone. But if we have a digital twin, we've always got that record, and hopefully an accurate record that we can come back to if we need to for any point. Excavation and profile control. This is a key one in SCL. A lot of you guys are engineers. One of our engineers on site here, SCL engineers. We've all seen them standing at the face, yelling at the miners, being yelled at back about how much shotcrete should go on. But perhaps we can use digital twins to look at excavation control as well as profile control of the tunnel and make that more accurate. I think things like sustainability, carbon, etc., are all very buzzwords at the time, but also very real. We need to start reducing carbon, so reducing excavation, reducing SCL usage, reducing concrete usage. So perhaps we can use digital twins to control profile, wastage, etc. Rock support and setting out, similarly, we can use digital twins to set out the rock support and then see if that correlates with the design and also the geology, which is the final point, which is geological characterisation. So we work in London clay a lot, but however, rock tunnels, etc., and other tunnels where we need to map the face and characterise the geology, perhaps we can use digital twins in that area as well. Moving on to lining and support. Again, I won't go through every single one, but what we can have is after we spray the tunnel or put the lining in place, we can have a 3D coordinated digital twin, and again that forms a record, an as-built record, but also for future use. We can geo-reference that, so we know where things are in space. That becomes helpful, and Marco will show you in some of his case studies how that becomes helpful. Thickness control for the nozzleman. I'll show you a couple of examples how perhaps we can improve the way of SCL application at the moment. Also profile control for the nozzle person, I should say, not nozzleman. That's a spelling error on my fault. Assessment of materials used, volumes, rebound, wastage, etc. And perhaps we can develop this to provide real-time continuous feedback to the operatives and the nozzlemen and keep them out of the face. And finally, asset maintenance and renewal. So once the asset's in operation, and the talk Marco is going to give is going to focus on the Brunel tunnels, historic aging assets, but they're still in operation. And asset and maintenance renewal for the asset owners is key. So what we can do is we can use georeference visualizations as a record, use them to assess the condition of the tunnel, characterize defects in the tunnels from these models, georeference them for positioning, so when we go to do the repair works, we can set them out. And that's the last point there, the defect and setting out tool. And this can happen quicker and with less boots on ballast, so less disruption to the public. I think night shifts, etc., where we can capture data and keep operatives away from the face, so to speak, or from dangerous environments, and also minimise disruption to the asset itself. So putting this all together, there's a lot of areas that we can use digital twins in the whole of the tunnel life cycle. So again, in my opinion, it's not just a 3D CAD model. It's all these things, and it can be all these things if we use them correctly and use them to their full ability. And not all of these things are developed. These are just ideas as well of mine and my colleagues, some of which I'll present later on. But in my opinion, all these things can help us innovate and make the tunnel life cycle, less disruptive, safer, and potentially reduce waste. A couple of projects that we've worked on in digital engineering. So this is a data capture, a 3D colorized point cloud of one of these Brunel tunnels. And essentially we can capture these over a few night shifts rather than disruptive access. And it provides a very high quality record. I won't go into the details, Marco's going to go into that, but essentially what it provides is a record, and we can have a desktop fly through. So we can take this away and sit with our clients at Network Rail, etc., and show them the defects, show them the tunnel, not all of them can be there, and have a discussion around a table with a visual tool in our back pocket to help facilitate. But we can also provide another angle. We can only see from inside the tunnel. But when we build the 3D model, it shows us all the contours. We can look from the outside of the tunnel. And we can start to see perturbations in the tunnel lining, perhaps overbreak or areas where bricks have fallen out, etc., which aren't clearly visible from inside the tunnelling. And it just gives us this second perspective and allows us to, again, make informed decisions and analyse the structure together, potentially with the asset owners sitting, here we go, here's a defect that we probably wouldn't see very clearly from inside the tunnel in a dark environment, but we can sit down with asset owners at a desktop in a safe place and start to analyse what these features are. So excavation and profile control tools, the sort of things we would like to use digital twins for is looking at underbreak and overbreak, thickness control of sprayed concrete especially, profile control, both excavation and as-built record of the lining, volume and rebound measurement, again geo-referencing things, and it'll be clear why that's important. Highly accurate point clouds, so we can go down to less than 10 mil accuracy, but 10 mil accuracy does give us a very good capture that we can look at, and then trying to analyse that data real time and feed it back. So this is an example of a tunnel that we worked on in Norway, which is a drill and blast tunnel. And what we were able to do is, once they captured the rock mass, we built a bare rock model, put the design profile in place, which is the black surface. Anything sticking out of that design profile is underbreak, and the colours behind it give us a depth of overbreak. So the data could be captured very quickly. We could analyse the profile versus design again very quickly, and report back to the operatives on site where they need to scale or where they need to do further excavation, etc., etc. Again, this is just another snapshot of the same tunnel. So this is a colorized point cloud contoured by distance from the design profile. Each one of these is in advance, and we've been able to stitch these together and give a real-time representation. Sorry, not a real-time, but a visual representation of the actual profile as opposed to design. So I put a big cross against real time because it's not. So at the moment, where we are is we get the data capture is very quick. The processing is quite manual at the moment, so Marco over there does a lot of the manual processing. It takes about 4 odd hours to do a full scan process and then feed that back on site. So I think in terms of digital twins, where we've got a lot of knowledge and a lot of ability to capture data and process that data. Where we're struggling at the moment and where we need to develop things is this real-time processing of that data and that feedback loop back on site and back to the operative so they can make use of that data quickly. The tunnel's constantly advancing. If we don't feed that back quick enough, it slows down the process and potentially, if it's too late, then it's not used. So I think where we are at the moment is we need to speed up that process and that link, and we'll get to that a bit later. But at the moment, we're roughly processing about 4 hours for every 50-metre advance of tunnel. So where we're going to next is continued development and automation. So what we'd like to do is improve that processing and feedback. As part of that, what we've done, we've just finished an MSc with the University of Leeds, and this looked at joint detection and mapping of geology. So what this slide shows is up the top here, this is the old process, where you've got a scan line on a rock face. Where we're moving to and this MSc looked at was using LiDAR scan, so one operative from a safe environment taking a scan, bringing it back and looking at whether we can map defects. This is the future, hopefully, sending in automated drones, etc., to do the same. Hopefully we'll get there. And again, so this down the bottom, photogrammetry, this is an older method and a slower method of using cameras, etc., to capture the rock conditions. But we looked at the use of LiDAR and whether that can be used to process geology. So here's an example of how that went and the process that Anthony Allen developed at the University of Leeds in his MSc. So we had a rock face here from a data set that was captured, and that rock face, as you can see, contains bedding planes, joints, dipping and trending in a certain direction. That was scanned in the LiDAR. We looked at different algorithms to see if we could identify the joint sets and colour them, and we were able to do that quite well. So from that, this is the mass of data that was collected by point cloud. Anthony worked with filtering algorithms to put this into a stereo net, so that's something that we use as engineers. So it goes from being a mass of data to an engineering tool that we can use, and then we can develop that into stability analysis. So again, Anthony looked at whether we can identify joint sets. From his analysis in this rock mass, we were able to identify 5 joint sets, and this was validated against manual mapping from the data set and the scan lines that had been done. And it's not a very good comparison, but long and short of it is he did get a very good result in terms of the 5 joint sets that the algorithm identified and that the manual mapping identified, and the dip and dip directions were quite close. So it seemed to work quite well in a rock face. It didn't work so well in a tunnel because we blast a tunnel and it creates many features and many more rock, surfaces. So it didn't work well. So the next step, and we've got a PhD in the making with the University of Leeds to perhaps look at how well we can apply that process to the tunnel. So long and short of it, where we've got to, the traditional mapping method of manual scan lines, etc., we've moved to looking at semi-automated discontinuity and geological characterization using LiDAR, and obviously what we're trying to do is fully automate that to detect discontinuities and also apply that in a tunnel environment. Right, so that's what we've done so far and where we are. Now I'll hand over to Marco, who'll talk through where we've applied this in asset management. Over to you. Thank you.
Thank you very much. You can see Anmol is the one with the ideas, and plenty of them. We try to keep up, and I'll show you something of what we managed to do in the recent past on the matter. So looking at Victorian heritage tunnels in the UK, just to set the scene, there's a very extensive and heritage network in the UK, 16,000 kilometers on the network, out of which 900 are tunnels, 900 tunnels totaling up to 400 kilometers. And we know it's the birthplace of tunnels, so the average age of operational tunnels is way past the 120 years design life. We are at about 150 years on average if we do the maths. So this means maintenance is key, and we all know that means disruption and funny signs like this, luckily, not just disruption. Disruption for maintenance is the least. If we don't do that, all tunnels deteriorate, and you probably all know this example because I've been shown this by, I think it was David Hindle in one of his presentations, so it's very famous. If we look away and we look away for too long and don't maintain, that's what happens. Other examples are Queensbury Tunnel, left too long thinking what to do with it, and until part of it decided to cave in. So maintenance is absolutely key, and especially on an operational asset. The current practice hasn't changed much since the beginning of time on the rail. So in the sense that it was already really good. This is a map of tunnels, historical, and a tracker of ongoing repairs in Sapperton Tunnel in Gloucestershire. You can see it 1904, 1907, and then subsequent campaigns. And inspections and repairs, because of the heritage asset and type of materials, are still what they were, and limited. Maybe we have better tools and MUPs, but the tool here on the right is still the main friend of inspectors. And naturally, standards have caught up. So what we look for is a range of standard defects. This is from Network Rail guidance. Generally, we look for lining defects as hints to what is happening structurally to the tunnel. So we look for spalling, open joints, water ingress that then causes degradation of the lining, and signs of what we cannot see, so hollow sounding areas, bulging, lining deformations, and then go tapping around and look for loose and missing masonry and cracks and fractures that tell us about how the tunnel is moving. And I'm sure you're familiar with this, but if you've never been face to face with some of these, typical spalling bricks in a brick tunnel, and very hard to capture, open joints to capture on pictures. You can just see that the mortar has been washed away from that joint on the right. Water ingress is a bit more is a bit better at manifesting itself. We can hear it, we can see it. Hollow spots, not that much, but inspectors mark them out for subsequent inspections. And then missing bricks, we can see them, even though in darkness, all of this is quite hard to spot, especially lining deformations when they're not apparent. This was a bit better in terms of identification, because we can see water ingress at the same location, but we did miss it on the first walk down the tunnel. So how we record all this? On standard sheets like this one, for example, which is a record down the chainage of the tunnel, along the arch, along the vault of where defects are. But the problem with this is that inspectors do have to inject some subjectivity in these inspections. So we can go from one inspection to the following, and all of a sudden 21 square meters of spalling bricks disappear because we haven't been able to re-identify the location where those were, or we overestimated them in the first place. So when we manage to track them down, maintenance follows and repairs, and as I said, we go from the classic repointing to recasing, and if we can, repointing mechanically, or just let go of the tunnel and have the beautiful bricks and spray a CL on it, which is sometimes the only way to save it. All of this, as I said, causes disruption to service, and we ask for the patience of travelers, but the main drive in the industry and for asset owners is clearly to keep people on the move and keep passengers moving. So how can we improve on this historical and well-rehearsed and working procedures? We can improve the quality of the information we capture. So we can use point clouds. As Anmol was saying, they can be extremely, extremely detailed, not to the 10 millimeter mark, but much more. So this was captured at, I think, 4 millimeters to a point every 4 millimeters, and we can see joints, we can see roughness on the voussoirs, we can see vegetation, and we can process all this. We can look at the tunnel from a different perspective. These are examples from, not the first one, but these ones are example taken from a scan of White Wall Tunnel. That was our introduction to the digital world, thanks to Murphy's gathering this data. So we can cut sections, we can characterize the tunnel, but we can also look at lining quality. We can see by the amount of reflected light how materials change. We can distinguish steel from concrete, for example, and wet concrete from dry concrete. But we can also read, we can identify where we are in the tunnel, we can read change markers and go down to the detail of measuring how much these cavities and defects are, if we talk about spalling bricks, like in this case, or be it core holes, or in this case bricks missing for drainage. And we can see what is really hard to pick up in the tunnel. Well, this one it's a pretty lousy example because there were already three steel bars installed there by someone that did notice it, but it can be quite hard to catch these bulges in dim light at night, but in the model they really appear very, very clearly. So we catch all this, we gather it all in 3D, but how do we communicate it? Because not everyone can put on some fancy goggles or open a CAD model and look into it. So we have to go back to the old way and to the 2D world. So we develop the tunnel and just unroll it, show it on a page, and we can add spatial references. So we can break it down in meter squares, like in this case, and start annotating it. So before we get to annotation, what can we see? This is a color plot based on depth from a theoretical design introduce surface. So we spread the surface on what the original face of the bricks would have been, trying to bridge over cracks and cavities. And we can see here in red and black things that are recessed from the lining. And like in this case, we can really pick up spalling, we can pick up open joints, and keep in mind that joints are down to 10 millimeters width, but they still appear very clearly. But this is a color scheme that doesn't really tell us much, so we need to go back again to the standards and to the standard classification. So for example, for network rail standards, the classification of defects is down to a 3-tier system. We have S1, S2, S3 for spalling, and so on for other types of defects. So we go back to our model and introduce that and go to a more simplified color scheme, and in which everything black is okay, everything green is that first tier, S3, which is the lowest, and then so on. And we've introduced this cyan to just clearly identify anything that doesn't fall strictly into any of these categories, or that is like a niche, like in this case. And if we look back at those examples of spalling and other types of defects, we can see that when we go back in the 3D, these become really apparent, and not only we know where they are, everything is on coordinates, and we can measure them. Even more for open joints, because, as I said, they're very hard to spot from inside the tunnel and very hard to gauge how deep the defect is. But if we look at the tunnel from the outside, like Anmol was showing before, we can really see, apparently, and these blades coming out and showing the location of open joints and the depth to which the lining is affected, because that the laser is free to travel in and return data. We can get an idea of where water ingress and quality of the lining from the intensity of the returned light. And again, even in darkness, we can shine light and see and contour tunnel deformations. So we can do this over the length of the tunnel and get to this tunnel-wide assessment that gives us a very high quality and measured idea of what is happening to the tunnel. Now the problem comes back to communicating these results. Again, nice, beautiful models. Well, if you share my view, they're thanks to the tunnel and the original historical asset, they are quite beautiful models to work on. But if we go back to the 2D world, this is, if you want, an enhanced version of what the current practice is. It is still 2D, it is developed, but we know where things are. We have those squares that tell us you are 5 meters from the closest from the closest change marker, for example. We can annotate where the lining changes. So, for example, those blue polylines at the top is where the lining has already been repaired and has got brick patches. And go on annotating with the standard codes so that a person that is used to using the standard sheets can pick up this one and say, okay, I know that one is 6S1, means I have 6 square meters that are spalling, but I know exactly where they are. Because everything is on coordinates, we can do something more that would have come later in the process. Knowing that repairs take space, require space and may affect clearances, we can look directly at what the situation in the tunnel is, and it won't be a full gauging survey, but it will give us a very good idea of where clearances will be affected by these repairs to the point that running clearances are reduced to substandard. So we take all this, and after a few trials, we got to a semi-standardized format, and we now use this kind of records, which is a similar sheet for 30 meters of the tunnel with all the information we need on material defects, with their extents, reference to pictures, and references to fixed assets in the tunnel, like change markers that tell us exactly where we are when looking at the drawings. So this is for material defects, and what we couldn't do in the tunnel directly, but again we can get out of the same set of data now, is a bit more of a structural understanding of structural risk in the tunnel. We know that deflections increase stress in the tunnel. If we don't know much about the material the tunnel is built with, we cannot directly put numbers to these, but we know where the tunnel will be overstressed. And if we see a deflection of 200 millimeters in over 15 meters, we know something has gone wrong, and we know where to look for which type of defect. The problem is, what was the original shape of the tunnel? Because we're dealing with historical asset. Was this supposed to be? Was this as-built, or should we start running? So we have to look back, and this is honestly a fun part of the job, which is getting away from the computer for a bit, even if they're usually digital records, and look at historical records. And these were really great drawings from the construction of Sapperton Tunnel. But again, this is from, I forgot the name of the book, but it is St. Anne's Tunnel near Bristol. And we found out from research that it was originally unlined, and we found record of what the lining was, but this can all hint to the reasons why the lining looks so weird in places. And again, it's not a digital twin, but it can serve to remind us of what geology was in the tunnel. Luckily, niches left unlined can give us an idea of what geology is. And we have more modern tools like BGS records. Well, modern in the sense that I look at them on a computer, but we have the British Geological Survey records of faulting and other geological features that give us a hint of where we could see deflections or damage to the tunnel lining. Like in this case, going back to Sapperton Tunnel, I'll just play this that shows tunnel profiles cut every 5 meters, and it's not super accurate and it's a bit fast, I don't know if you caught it, but going through that fault, we could really see that the tunnel profile suffered the highest deflections and changing over a very short span. And we could trace it back and find a reason for it and know that it wasn't probably built that way. We can also use other tools. We try and connect the dots and look at the tunnel holistically, not just sections, but for example, in this case, if we see that the crown at some point has gone down by 240 millimeters, is it settling, or was it the other way around because something pushed from the sides? And whether that's likely or not, well, we need something. So if we look at the portals, in this case, we can see that the string course has settled 200 millimeters as well. So if we have to choose between those two shapes, we can probably tell that the blue one is the original one, and then something happened that caused it to settle. So going back to that structural shape, what can we tell out of this, and how can we connect these different sets of information? Or we can look at what the type of, what defects we are expecting to find in areas of particular overstress. So will it be spalling where the lining is overstressed on the introduce? Yes. And will it be more likely to find open joints where the lining is sagging in? So if we know that, we can target our repairs to areas that have signs of structural distress and are not maybe just damaged because of freeze and thaw that cause the bricks to spall away. So we can look at these two layers of assessment. We have not the old, but the initial traditional material defect assessment that shows us spalling and water ingress and all that. And we have a structural risk assessment based on the shape of the tunnel. We can put the two things together because we know perfectly well where they are thanks to the digital capture. And where these things overlap, we can say with certainty that we have both the cause and the effect of overstress. And we know that if we are short of resources and time, we can go there first. And to make it more immediate, because we need to summarize all this for people that need to look at many pieces of asset and much information in their day life, we summarize it all with a repair and priority rating, which is based on this matrix intersection of the two systems. And this is an idea of what I suppose an asset owner would like to see as a snapshot of his tunnel. So this just shows what is the affected area of the lining at each 30-meter change interval and what the running clearance is there. So in a snapshot, I can assess the tunnel and say, okay, that area needs a lot of repair. Have I got the clearance for that? No. Then I need to start thinking seriously about what disruptive work I will have to do in there. And all this, as I said, is a snapshot of where we are, but it's continuously being developed. We have developed this starting 2018, 2019 on Whitewall and Sapperton, but we've then moved on to other types of lining. So we've worked on some fantastic bathstone and rock tunnels near Bristol, like these ones on the right, and even some sections that were left unlined, where the joint characterization that Anmol was showing us before becomes really precious, a really precious tool. So how can we add value with this? We add efficiency, because we can capture all this data and look at all the work that we can do without having to step back in a tunnel until we know exactly where to go. We add repeatability, because it's unlikely that we'll walk back in and not find those 20 meters of spalling bricks, because we know where they are and we've measured, and we can objectively tell that there were that kind of defect, and we can optimize repairs. We've started with brick tunnels. We moved on and looked at what we can do for other types of assets. And looking at cast iron tunnels, for example, different sets of defects, but still any information we can get on the assets can be really used in this way. So this is a pedestrian access tunnel, and it looks really bad. We don't know, the asset owner was a bit in distress, walking down for inspections and thinking whether the asset was still serviceable. Scarce records on construction and lining details, especially the lining was non-standard lining types, and we didn't really know why it was built that way. So we didn't really have much to work with to tell whether this tunnel was still safe to walk in or not. So we went and scanned everything, and then took it away, and we applied these digital assessments, cut sections. However, first we started with every 5 meters, then went down to 2.5, and even a ring that looked perfectly fine, when properly analyzed, can tell us a lot about ovalization, which way the ring is ovalizing, and we can start connecting dots and seeing how the neighbors are doing and if there is a recurring trend. So we go from this real color model to a color-coded model similar to what we were looking at before, that tells us where the lining is bulging and in which way. So we can then take that and, knowing what the ovalization is, look at whether the capacity is exceeded there, because luckily in this case we know a bit better what the material is capable of, and make an informed assessment at very many locations in the tunnel, and not just a few that we could have measured with a tape measure in the short access windows. And where do we go next from here? I'll hand back to Anmol for the plan for future, and let me know what we're doing next. Thank you.
Thank you very much. I don't think I have a plan for anything, to be honest with you, but plan for the future. I think it's just some ideas, and I think this is very open to everybody. They're just ideas of where we think the developments would like to go next. Before I start, though, I think I'll just say that what Marco showed is a bit of a continuation of what I was saying, is that we're getting a huge amount of data, but we're getting those metrics, and metrics that we as tunnel engineers understand: ovalization, spalling, loss of mortar joints. It's not just a nice big 3D CAD model that someone with the brains like Marco can look at. It goes back onto a sheet of paper. We get it, we unroll it, it goes back on the sheet of paper, and the guys walk down at night time with the sheets of paper, but with all that data in an informative way. So it is bringing the data capture from the digital twins and making it useful. And I think that's what I was trying to say at the start is, what is a digital twin? It's something that gives us augmented reality, but we need to use it in a nice way. So where to next? So this is the old method of how we communicate the results. So as Marco said, we basically, at the moment, we produce a sheet of paper, a set of drawings with all these defects, but they still need to go out and mark these out in the tunnel. And unfortunately, it's still the old way of a MUPE and lights, etc., and trying to go and identify these in the dark. Not easy, and I think what we would like to do is develop a tool that, having done all the data capture and analysis, allows the guys to go out and see these more visually. So what we're thinking about is this sort of thing. So we're looking at technologies from other industries. I don't know how to play this. I think I just click. But if you have a look at the guy in the top left, top left is an app for the building industry. The company that makes it is up there. So we're just looking at other industries and see, can we bring that into tunnelling? And you can see what they're doing here is that having a georeference model, they've got this, that someone's developed this app where you can walk around the building, move the app around, and it will show you where pipes are supposed to go, where M&E is supposed to go, etc. So our idea is to maybe borrow these ideas from the other industry and set up something that we can walk down the tunnels with an iPad, etc., and it would give you something like this shown up here, and it would mark out the defects visually, so at night time it'll be easy to identify. Other things, we've trialled this in some tunnels: thermal imaging, so using different technologies, not just laser scanning. Thermal imaging is quite good. It actually shows us, this is water ingress, but it can show us very small areas of water ingress or potential holes behind the lining. So we're looking at using thermal cameras, like I know Benoit developed the use of thermal cameras for shotcrete, so that the idea kind of popped into our head. We tried this out. The other thing is ground penetrating radar. Sorry, there's a comparison. I'm one slide ahead. That's a comparison of the thermal image and actual water ingress. We're looking at ground penetrating radar. This is a drone system that has ground penetrating radar captured on it. One of the deficiencies at the moment with our work and our development is that we can't get a tactile survey on the lining, so it's visual only at the moment, so we can't identify drummy bricks and hollow spots. The fellow with the stick is still the go-to man to figure out where hollow spots are. We can't tell him what to do. So at the moment, it's all non-tactile, but potentially using a ground-penetrating radar or something of the similar mounted onto an instrument or a drone, and that can be put up against the lining, would help us identify hollow spots. I'm not 100% sure where this image came from, but it's been used in the past to identify holes. We're working with some industry partners, Normet in particular. They've developed their smart scan. I see Ross Dimmick's in the crowd, and probably correct me if I'm wrong if I put crosses and ticks in the wrong spot. But at the moment, we think of all the things we'd like to do. The ticks summarise what the smart scan can do, and the crosses what it can't do. And I think, oops, sorry, just before I move on, I think the key is this feedback loop here. So we can potentially work to develop many of these, but it's how do we feed that back at the tunnel face. There's a picture of the smart scan in operation. The good thing about the smart scan or any sort of similar system is that the shotcrete robot is generally the first thing down at the face after it's been excavated. So that is potentially a tool with a boom on it that we can use to capture the data and also use for profile control. In terms of feedback, a few ideas, how to snoop around. The top picture here is a sandbox, and this is by the US Geological Survey, I believe. And what they do here is they have a projector, and it contours the change in elevation. So you can see this guy here is making holes and mountains, and the projector beams onto it and figures out the change in elevation. But you can see how this might go into profile control. If we had some form of smart scan tool that does the data capture and a projector somewhere in that tunnel that projects onto the face, using technology of this this nature, then we might be able to colour contour for the guy at the face where red is undersprayed or oversprayed, and where blue is okay or green is okay, and people like my friend Julian wouldn't have to shout at miners anymore. So that's one topic. The aerospace industry, they use lasers to project decals onto their aircraft. So we see a lot of aircraft with very intricate decals and paint, and how they do that is, again, it's a georeference system with lasers that projects onto the plane what needs to be painted, and it measures distance, etc. And again, these are sort of technologies we can look at outside tunnelling that potentially we could harness and bring into the tunnels to help us make the process more efficient. Again, we've got, sorry, this is a repeat up here, but the guy down the bottom is wearing Google glasses or something similar. And again, I think for profile control or anything in the tunnel, augmented reality might be a process, and this idea came up again from the aerospace industry. Fighter pilots wear heads-up displays and those sort of things, and I think we'd look pretty cool walking down the tunnel with those things in as well. But the ideas are, the technology exists, and it's a matter of bringing it in. I think going back to this figure here, the hard part is taking millions and millions of points and processing that quickly. At the moment we have computer power, but we have people writing the algorithms to solve it, and it takes time. SLAM technology, etc., is coming up with semi-real-time processing, so we can get a quick assessment of what's happening. But again, it's feeding that back in a safe way. I know these look really cool, but I'm not really the biggest fan of glasses unless we can see inside the tunnel. Obviously, there's safety issues to consider. It's hard enough as it is in the tunnel. And once the shotcrete starts and the circus starts, it's difficult. So you need all your senses. So I think they're just ideas, and I think I'd like to put these slides in to get everyone thinking about it and see any ideas that we as an industry can put together and put forward. Hopefully, develop these to start automating processes. I see Alan's here as well. Alan's down the face. He's been there for a long time, so I don't know what you think, Alan, but I'll catch you at the pub as well and see what you think of these. And finally, we could get the drones to do all the work. I don't think that's ever going to happen, but there we go. That's one for the future. But that's it. So relax. The presentation's over. I won't say who or where this is, but it's just catching up on some rest on a night shift, which is obviously well needed. But yeah, that's it for us, I think. So thanks for your patience, everybody, and congratulations again, Bob. I think it's well deserved. I'm really glad to be looking at new technologies to work with the likes of you guys and use all that knowledge from the past, and hopefully collaboratively work together and push the industry into well, not into the new age, but bring tools in for the new age. I don't think we could ever replace the inspectors or the miners. Their knowledge and their experience is exemplary and paramount. But I think we could complement their experience and give them tools to make it easier and make it more efficient. I think that's it. Thank you.
Okay, we have 2 roving mics this evening, and just a reminder for those of you that were here last time, we also have a wet wipe process. So when you take the mic, if you could just clean it before you pass it on to the next person. So those with the mics will explain it in a little bit more detail. So any questions? I think we've got one at the back if we start with.
Thank you for a very illustrative presentation. So I do apologize, I'm not a tunneler myself, but I come from the data science side. So you mentioned the question of processing time and trying to optimize that. Making reference to some other areas, for example, anomaly detection in geology, where they try to see where the cracks are for earthquakes, or cancer detection, for example. We use that in finance as well to try and find outliers. In terms of not scanning the whole stuff, but using a combination techniques, we can follow this offline, a combination of SVA and DB scan, so support vector analysis with DB scan, or as PCA and DB scan can optimize the time very quickly and pinpoint just the anomalies. So you're not, if you want to do the work, I take it that you're not worried about the whole tunnel, but just want to understand where the lining is cracking, where the spalling is. So exploring some of examples, as I mentioned in AI, can quickly optimize the time analysis and give you a real-time analysis sometimes as well.
That would be very welcome.
Okay. We have another question just here. If you could just say your name and affiliation as well.
Hi, I'm Christina from VAM. You gave a definition at the start of digital twins, and it seemed that real time was quite important. And I was wondering how what you've showed is different to a BIM model, essentially, because it seemed like a lot of the data is, like maybe the analysis is real time, but you're not collecting data constantly. I might have misunderstood completely, but I just want to understand how that's different to a BIM model. And thanks for the talk, it was very interesting, especially the contouring for SCL. I think that's a really interesting idea.
That's very true, and I'll just say something first if you don't want to follow up. The way we think this innovates also, and we haven't really addressed that in the presentation, is that it represents a real digital twin in the sense that it is a live record of condition of the asset. So true, the data is collected at given and finite intervals, but it can be fed back thanks to the fact that everything is very, very accurately. It is perfectly, precisely spatially referenced. So we can use scans taken at different times and data gathered at different times to monitor and deform and move this digital twin of the structure accordingly, and that way have a real idea of the development of the health of that structure. So in that sense, there is a time element as well in this kind of analysis that we haven't really addressed or investigated at this stage, because we are doing the first scan of hopefully a series of scans that will give us a better idea of evolution of conditions over time. I don't know if you wanted to add.
Okay, got another one just here.
Hi, it's Tom Emerson from SCS Railways. I was just intrigued as to who hosts your data and whether any other contractors have access to it.
Well, the data goes back to the asset owner, and how easily then that is accessed again by the next person working on the same tunnel is still a bit of a mystery, because it's all new, and you probably know very well the size of these data sets, and we've try and optimize and reduce them to the bare minimum that we need to process them, but it does take time to move this amount of data, and it takes space to host it. So definitely there is some room for development in making records more accessible, and I think that will come with time as these things become more widespreadly, widely applied. But it goes back to the asset owner, and that's for now the source for historical information.
We've got time for another question. This one just here.
Hi, so thanks for the presentation. It's Matteo Iacorossi from Arup. So I was just wondering, is there any technology to do the scan underwater, for example, in water tunnels with an unmanned sort of vehicle, or like a small submarine, but in clean water?
I don't know, we've never investigated it. I've never seen laser scanners work underwater for now, and it does.
Or maybe another technology, if I could be.
Yes, definitely. It is.
To empty the tunnel. Well.
I think it's a problem with radar as well. Just water, usually in ground penetrating radar, I think it does influence the data when there is the water table really high close to the surface. So I'm not sure what could be used in that case. Probably some. Not an expert, I'm just speculating. Maybe sonar or.
Yeah, I was just going to, maybe sonar, you could try. I would think it's just sounding echoes rather than light, so it might
thanks,
be.
Yeah, I think it could be interesting.
Yeah.
Okay. One more down here.
Yes, I was interested in when you were talking about the techniques that could give you data to help you build up the digital picture. I wondered, you spoke about ground penetrating radar particularly. I wondered if you looked at any other techniques like microgravity or ultrasonics to actually also inform the model.
Not yet. I come from a from a survey background, strong thanks to the people I worked with, and so I'm comfortable with light, laser, and reflected signals. Very interested in looking into different techniques, but they're very much out of my reach. So that's something for collaborations.
Yes, it struck me that that with these techniques and with what you're doing, the important thing is the ability to handle an awful lot of data and actually manage that data, which is quite key. And it seemed to me that those kind of techniques, could fit very well.
and definitely to give us more information on what is behind the lining, which is what we're struggling with at the moment. Yes. Thank you.
We have one more at the back.
Rod Young from Barhale. Two bits of question, really. Being able to use it in water would be brilliant, because a couple of years ago we had to drain down 16 kilometres of 100-inch tunnel to be able to inspect it. And going forward from that, when we inspected it, we had to do it physical because it was 100-inch wedge block. And we were concerned that if the rat bags had come out, it would be replaced by clay. Now, you mentioned you could pick up the difference between concrete and brick. Can you pick up the difference between concrete and clay? Because we were concerned that the clay was just replacing the rat bag and you wouldn't actually see it without a physical inspection.
Yeah, so let aside the limitation with underwater, which I'm not sure yet how could be addressed. Definitely at times, and not just at times, physical inspection is required. And the good thing with these tools is that they can guide that in-person inspection. It won't take away the need for a trained and experienced eye to look at the structure, but it will tell us where better to direct that very well-trained eye and use his time or her time in the right way. So totally agree, sometimes it is needed.
But would it pick up the difference between clay and concrete?
Possibly if they're next to each other, because of the way they reflect light and the amount of light that is reflected. And if there were the only material picked up in the survey, it might be difficult. These techniques are good at identifying differences and spotting differences between different materials, different surface conditions, roughness, wetness. So if we put a piece of concrete next to the set, probably yes.
I think that looks like we've drawn a close to the questions for this evening. So I just want to take this moment to thank Anmol and Marco for joining us this evening. I think it's really encouraging to see some of the developments that you've made, and from the range of questions in the room, I think there's a lot of enthusiasm for you to keep going. I think if you can solve the water challenge, you've got a few people that would be interested. But yeah, it's really interesting to see where you're going in this space. So thank you again for joining us this evening. So could you please, So I do have a couple of announcements this evening, which should be working their way onto the screen. So if we could move on to our next slide. So the first one is, sadly, the ICU bar is not open still this evening. However, we have our temporary home for the BTS bar is downstairs at the Westminster Arms. So I hope many of you will be able to join there this evening. So yeah, a different venue, but same tradition in terms of food availability. And this evening, we have the food sponsor for the very famous BTS sausage and chips of Bedi Consulting, and our drink sponsor this evening is LBA. So thank you to both of you for this evening. So one of our next events is a BTS-YM online workshop on Thursday, the 2nd of December, and this is on soft ground tunnel design by Dr. Benoit Jones. And for that one, pre-booking is essential, so please follow the links on our website for more details. The next BTS evening meeting is on Thursday, the 9th of December, and that's the Thames Tideway Tunnel Update 2021. For those of you who've been with us for many years, you'll notice that we've had a few of the Tideway updates at Christmas, so looking forward to see what they're bringing for us this time. Then on Thursday, the 20th of January, we have our next BTS lecture, so the first one of 2022. And this one, the topic is a little bit at large, so bear with us on that one. However, before that, we will be having a special general meeting, which we will be emailing all members about, to look at a very minor change to our constitution that we want to put in place. So look out for more details on that one. Then on Thursday, the 10th of February, we have the BTS and Min South joint evening meeting on the Kidston Pump Storage Project from Queensland, Australia. So in addition, as we always say, if we've got any papers or lecture topics or something that you want to share with us, please get in contact either with bts@ice.org.uk or with Sarah Langley. So just as a reminder, hopefully many of you have either already done this course or you were booked on to join us next week. We have the next BTS Health and Safety course. This is a really interactive course, which is why we were not able to host it during the pandemic. There are still a few spaces left, so if you haven't yet registered and you are available next week, please can I encourage you to join. So yeah, please follow our link to our website to join, and we take bookings all the way right up to the Monday morning. Next event then is a reminder about National Tunnelling Day. This year it's on Friday the 3rd of December 2021. Please share your stories with us and keep an eye out on the BTSYM social media for further information of how you can get involved. Then on the 18th of March, the BTSYM conference returns. Again, check out social media for the call for presentations and further updates. Another event that we've really missed not being able to hold. Next up then is a reminder, there are some discounts also for young members for the NCE Tunnelling Festival. Right, then another one, the Harding Prize 2022 is coming around very quickly. We are looking to receive any original papers on any subject, however relating to tunnelling, by the 11th of February. It's open to any individual aged 33 or under. Last year we had quite a significant number of entries. Looking to be having the same numbers this year at least, if not more. It's always a great event, and it's always really interesting to hear all the different things that people are doing. So please take the time to write a paper. Then we also have, will be the first Doug Allenby Memorial Medal. So we will be calling for applications shortly. That will be opening in December, and the medal will be awarded at the BTSYM conference. And this is a new award which will be awarded to a member of the tunnelling and underground space industry having up to 10 years of relevant experience for making a significant contribution to a project, team, or the industry. Next slide then is about the advances in tunnel management. This is a Syria, they've called it P3217 paper. If you want to get involved and find out a little bit more, please share your views on the SurveyMonkey on this link, and I think this will be distributed around further as well. So please engage, really interesting piece of work here. Then just a bit of a reminder about tunnel skills. Lots of things going on in this space at the moment, and all detailed guidance is available on the Tunnel Skills website. And really this is along with feedback or any other information that you want more information on. Contact immersivelearning@tunnelskills.org. Another reminder for those of you that have been with us during our virtual period, it's just a reminder that we actually introduced a number of BTS tunnelling songs. So for those of you that didn't hear about them whilst we were online only, something a little bit different. I don't think I ever thought that the BTS would be involved with commissioning songs, but we have some of our own songs, and at future events we will play them. Divik, looking at you. For those of you that haven't heard them, please find out more about Nancy Kerr, fantastic lady, and listen to the songs that she's created linked to all the stories that have been shared with the production of the book. She got a lot of inspiration. So then the book, the BTS 50th anniversary book. So we currently have a significant number of stories and lots of kind of introductions that tie it all together. It's about 856 pages at the moment. I think it says it could go up or down, and I think it's probably only going to go up. You have got so much to share with us, and this is a bit of a, you only turn 50 once, so we want to make sure we capture everything. So please continue to engage, but as you can see, progress is moving at pace, actually. And for those of you that were at the BTS conference, you will have seen some of the samples just to see the size of what 856 pages looks like. It's not one you'll probably be carrying around with you every day. And also just a few samples to see what it would look like. So a lot of work has gone into what it looks like. So, however, we do still need some help and support. So like I said, it's a once in a 50-year life cycle moment. So we've got a few gaps to close so that we can make sure it is a true reflection of what's happened in our industry. So we've got a few leads on some gaps, but there are still some more bits to do. So please can you let Ken Spivey know if you would like to provide one or more pieces, or if you know anything about helping us to join the dots. In some cases it's just trying to find people that we've been given the gravy trail of names for. So yeah, if you've got some time to write and would like to contribute to it, please let us know. And Ken is taking very small contributions as well as very big contributions of time. So even if it's something really little, it would really help us. So programme, as I said, obviously we need requests still for help. There's an enormous amount of people that have already helped. So our programme is quite linked to the speed that we can close the gaps. We are still currently hoping to be able to go for print in April 2022, which really isn't very far away, with copies being delivered sort of April, May time, and we're hoping to have pre-ordering in place before Christmas, although we've got a few printer issues. And those that have already sort of engaged with the pre-ordering process will be notified when it opens. And you can also register on the BTS website or by contacting one of the book team. So as you probably can see, a lot of progress. However, I still will remind that there is still a little bit of space for sponsors. So if you haven't yet got round to it or want more information on how you can sponsor this book and have your logo on it as well, please get in touch also with Ken. And yeah, a virtuous cycle. Okay, so that's all from me. And I've just remind you that we've got these codes and numerous ways that you can engage with us across all social media platforms. And I look forward to seeing you next time. Thank you and good night.
Thank you.